This is a lesson of simplifying rational expressions. The essential question is, what is the difference between terms and factors, and how is this relevant when simplifying rational expressions? As we move forward into the examples, we're going to be using these three look-fors over here on the right-hand side to help us with the factoring process in order to simplify the rational expressions. So please pause the video and take a moment to write these three look for when factoring steps down. All right, so factoring. So previously we discussed that, Previously we discussed that a factor is when we have items that are multiplied together. So 2 times 6 equals 12. The 2 and the 6 would be factors. So we're going to be expanding that idea, and we are going to be moving into factors that are variables. So x times y equals z. So the factors would be x and y. And it can get more complicated than that. We can have 2x times x plus 2. So 2 and x are factors because they're multiplied together, and this 2 and x are being multiplied by the x plus 2, which is grouped together. So we have a factor of 2, a factor of x, and a third factor of x plus 2. So again, factors are items that are multiplied together. Terms are items that are added or subtracted together. So we would see that in this example over here, x plus 2. This x would be a term, and 2 would be a term, and these are added together. Or we could have something like x squared plus 3x minus 1, and again, we have three terms, x squared, 3x, and minus 1. So how is this relevant when it comes to rational expressions or rational equations? So let's simplify a fraction. Let's do 12 over 18. We know if we put that in as a decimal in the calculator, this would be 0.6 repeating. If we factor this, the greatest common factor with 12 and 18 is the number 6. So we'd break this up into 6 times 2 over 6 times 3. These factors of 6 would reduce or cancel out, leaving us with 2 over 3, which, again, if I type that in the calculator, would be 0.6 repeating. So 12/18 and 2/3 are equivalent fractions. Well, if we attempted to simplify this by using terms, let's see what that would look like. So 12 over 18, a term, well, using the number 6, we could rewrite 12 as being 6 plus 6. 18, we would rewrite as 6 plus 12 to have common terms in the numerator and denominator. Well, if I canceled those common terms, that would leave me with 6 over 12. So 12 over 18 was 0.6 repeating, and 6 over 12 is 0.5. These are not equivalent. Those are not equal to each other. So we cannot simplify with terms. We can only simplify and create equivalent fractions with factors. So let's do some examples of simplifying a rational expression. So first thing we're going to look for when factoring, to simplify, right? Because to simplify you have to have a factor. We're going to look for, in the numerator and denominator separately, any common monomial, meaning a common number or a common variable. 4x plus 20, well, 4x, 20, what's in common with those two? The number 4. So we have 4 times, and what would we have to distribute that to get x plus 20? X plus 5. And again, that's because 4 is 4 times 1, and 20 is 4 times 5. So we have the greatest common factor of 4 from each of those terms. So if I factor out of 4, I have 4 times x plus 5, and in the denominator, I have x plus 5. In the numerator, I have factors because we're multiplying, but in the denominator, we have terms because these are adding. So how could I turn this into a factor? What would I have to multiply it by to still remain x plus 5? 1. Reducing this, we can now reduce it because we have factors. We have a multiplication. So x plus 5 and x plus 5 reduce, leaving us with 4 over 1, which final answer is just 4. So all of this, 4x plus 20 divided by x plus 5, is simply 4. All right, let's try another one. 10v squared minus 10v divided by 8v squared. Again, I'm going to look for any common monomial. Numerator, I see you've got a 10 and a 10. So that's a common number, but I also see a common variable. V squared is v times v. So I have a v in this first part of the term and a v in the second part of the term. So 10 and v is common and can factor out. So numerator, if I have pulled out a 10v, what do I multiply by 10v to get 10v squared? Well, that would be v. And what do I multiply by 10v to get negative 10v? And that would be negative 1. In the denominator, I have a single monomial. So I've got this 8 and v squared. And remember, v squared is v times v. So I do have factors in the denominator. And I have 10v and v minus 1 as factors in the numerator. So what's in common that can reduce or cancel? A v here and a v here. 10 and 8, well, they have a common factor as well, and that would be 2. So 10 could be written as 2 times 5, and 8 could be written as 2 times 4. So the 2's would cancel, leaving me with a 5 in the numerator, a v minus 1 in the numerator, and in the denominator, it looks like we've got a 4 and a v. So we have 2 factors in the numerator, 2 factors in the denominator. None of these factors have a common factor. So our final simplified answer is 5 times v minus 1 divided by 4 times v. All right, I'd like you to take a second to pause the video and try this third one on your own. Hopefully you noticed that 56 has a factor of, well, 56 is 8 times 7. 48 is 8 times 6. So we have a common factor of 8, leaving us with 7x plus 6. Denominator, 40 and 32, also have a common factor of 8. So 8 times 5 is 40. 8 times 4 is 32. So factoring out the 8 would leave us with 5x plus 4. I have a factor of 8 in the numerator, a factor of 8 in the denominator, which are common factors, so those would reduce. And I have 7x plus 6 divided by 5x plus 4. All right, so now let's try a squared minus 10a plus 9. First, we want to look for any common monomial. There's an a here and an a here, but not an a here. 10 and 9 do not have any common factors, and we have a 1 here, and 1's a factor of everything. So I have nothing in common in the numerator, and if I take a peek at the denominator, I have no common monomial there either. So now I want to look at my quadratic, ax squared plus bx plus c. There are 2 scenarios. One where a equals 1, and the second scenario when a does not equal 1. In both cases for this example, I see that a does equal 1. So I'm going to use the product sum method to factor this. So in the numerator, I'm going to be looking for 2 numbers that multiply together to get 9, but add together to get negative 10. So listing out my factors of 9. 1 and 9, negative 1, negative 9, 3 and 3, negative 3, and negative 3. The pair that adds up to negative 10 is negative 1 and negative 9. So we have our factors of the numerator, x minus 1, x minus 9. The denominator, this time we're going to be looking for two numbers whose product is 2 and whose sum adds up to -3. So factoring 2, I have 1 and 2, -1 and -2. The pair whose sum is -3 is -1 and -2. So the denominator will factor into x minus 1 and x minus 2. So I went from having 3 terms in the numerator, 3 terms in the denominator, to having 2 factors in the numerator and 2 factors in the denominator. We can reduce factors. So I see our common factor in the numerator is x minus 1, and denominator is also x minus 1. Our final reduced fraction would be x over 9 divided by x minus 2. All right, last example. Let's move this way. N minus 1 divided by n squared minus 4n plus 3. In the numerator, I have 2 terms, but I need a factor. So if I were to create this as a factor, I would multiply it by 1. In the denominator, again, I see that I have a quadratic here, and in front is a 1, so I'm again going to use my product sum method. Numbers that multiply together to get 3 and add together to get -1. So that pair would be -1 and -3. Numerator, oh, not an M, an N. N minus 1. Denominator would be n minus 1 times n, nope, not plus 3, minus 3. All right, and numerator, denominator, common factors, n minus 1 and n minus 1 would cancel. Remembering we did have a factor of 1 there, so now we have 1 over n minus 3.